Okay, on this video we are going to actually calculate the coefficients a0, an, and bn. Okay, now assume that you have a periodic function between minus pi, and the period is actually 2 pi. Now, we are going to assume minus pi and pi of the periodic function because of these formulas that we are going to need. Okay, now the method to find the coefficients is going to be by taking the integral of the differential of x from minus pi to pi on both sides of the function. Minus pi and pi differential. Now, why between minus pi and pi? Because it is going to cover exactly the function, right? Now the rest is going to be just repeated, right? So all we need is just this period of time from minus pi to pi. Now the f of x is actually the periodic function, alright? Okay, now if we do the integrals, it's going to be the integral from minus pi to pi of f of x differential of x equal to the a0. Now these coefficients are supposed to be constant, okay? So it's going to be integral from minus pi to pi a0 differential of x plus the integral from minus pi to pi of the addition of the summation of n equal to 1 to infinite an cosine of nx plus bn sine of nx and then differential of x. Now we need to calculate each one of the integrals. Now this one doesn't have a problem, but here we have a problem. What we are going to change here is to apply first the integral and then the summation. Now here is first the summation and then the integral. Okay, so we are going to switch this. So it's going to be the integral from minus pi to pi f of x differential of x equal to, now this integral a0 integral from minus pi to pi differential of x plus, here as I said, first the summation of n equal to 1 to infinite, and then two integrals, this integral and this integral. Integral from minus pi to pi an cosine of nx differential of x plus the integral from minus pi to pi bn sine of nx differential of x, and then you close this one. Now, okay, now as I said before, the coefficients are constant because we are taking the integral with respect to x, so this constant can be taken outside. Okay, so this is the same, this is the same. We are going to just change this. The summation of n equal to 1 to infinite. Here is going to be the an outside. Integral from minus pi to pi of the cosine of nx differential of x plus here bn taken outside of the integral, bn integral from minus pi to pi of the sine of nx differential of x, and then you close the summation. Now here is why we need these formulas. The integral of the sine of nx from minus pi to pi happens to be 0, and also the cosine. So this is 0 for any n, and this is 0 for any value of n, for any integral of n. So that means that all coefficients of an and all coefficients of bn times 0, they become 0. So all this summation happens just to be 0. So the only thing left is this part. Now, the integral from minus pi to pi of the f of x differential of x equal to a0. Integral of differential of x is just x from minus pi to pi, and we do the upper limit minus the lower limit. A0 is going to be pi minus pi, so this becomes 2 pi, so this is 2 pi a0, and this is equal to the integral from minus pi to pi of the periodic function. What is this f of x? Is actually this one. This is the f of x periodic function. Okay, so from here we can clear the value of a0. A0 is equal to 1 over 2 pi integral from minus pi to pi of f of x differential of x. Now, with this, we just calculate the first formula of the first formula to find this coefficient. Okay, we still need to calculate the an and the bn. All right. Okay, now it is just one of them, but still we got the first coefficient. Okay, keep in mind this formula. Now let's calculate the other two, an and bn, and the process is going to be very similar. All right, so I'm going to clear this part because we are going to calculate. We are going to make another calculation. Okay, now how are we going to calculate the cosine, the an and the bn? So this is what we are going to do. What we are going to do is to this, this is the Fourier series. Okay, but instead of just applying the integral, what we are going to do is this. We are going to multiply times the cosine of mx. So the function of fx times the cosine of mx, and then apply the integral from minus pi to pi. Okay, now this is the left side. We multiply this function times the cosine of mx and then apply the integrals. And then the same happens on the other side. So a0 times the cosine of mx, a0 times the cosine of mx, and then apply the integral from minus pi to pi differential of x, and then plus the summation of this. Okay, we are going to skip some steps. Okay, I'm going to continue here because I'm going to need more space. We're going to just in the previous, we are going to change the integrals by the sign, by the summation. So I'm going to write first the summation from n equal to 1 to infinite, and then integral from minus pi to pi an cosine of nx, and then times the cosine of nx, cosine of nx differential of x, plus the integral from minus pi to pi bn sine of nx times the cosine of mx differential of x, and then you close all that. All right. Okay, now the a0 we can write it outside because it is a coefficient. A0 here. The an we can take it also outside, an, and here the bn, I'm going to write it like outside of the integral. Okay, now here comes the formulas. The left side is still the same, integral from minus pi to pi f of x cosine of mx differential of x, and this is equal to, now the cosine of mx, where m is actually an integral, so it doesn't matter if it is n or m, the integral of the cosine, this is 0. 0 times a0, well, it is 0. Now, here, the cosine of nx times the cosine of mx, it is actually this formula, cosine and the cosine, okay? It's not 0. It is going to be 0 as long as the n is different than the m, alright? So this, we cannot make it 0. But, what about this one? When it is the sine and the cosine, it doesn't matter if they are equal, the n and the m, they are equal or different. All of this happens to be just 0. So the only thing left is this part. So this is going to be 0 when n is different than m. And it's going to be pi when n is equal to m. Okay? Now, because we have a summation from n equal to 1 to infinite, all of them are going to be 0 except when the n happens to be equal to m. Okay, so it's going to be times, so an integral of this is going to be pi when n is equal to m. So it's going to be just pi. Okay? Now you may wonder what happens to the others, because we have a summation from n equals 1 to infinite. Well, the rest are 0 except when n is equal to n. So it's going to be equal to pi when n is equal to n here. Okay, now from there we can calculate what is the value of an. When an happens to be this pi to the other side, 1 over pi, integral from minus pi to pi, f of x cosine of, I'm going to change this n by n x differential of x. Now, here is the formula to calculate the an. Okay? Now, you may wonder, how are we going to calculate the bn? Okay, now the bn, I'm not going to do the process, but the bn is going to be very similar, but instead of multiply times the cosine, it's going to be the sine. Okay? Now, if it is going to be the sine, then here is going to be a cosine and the sine, and they are going to be 0. But here is going to be the sine and the sine, and it's going to apply the same as this. So the result is going to be very similar. It's just that instead of being the cosine, it's going to be the sine. So I'm going to write the formula. Bn is going to be the integral, is going to be 1 over pi, integral from minus pi to pi, f of x, sine of nx differential of x. And here is the third formula. So these three formulas are the formulas we are going to use to calculate the coefficient. So now we have the formula A0, we have the formula for BAN, and we have the formula for Pn. Okay, next video we are going to do an exercise. We are going to do an example of how to calculate the coefficients, alright? See you on the next video.